Thank you, Linka, and thanks Sisters community and itabi.org community for providing me with this opportunity of presenting this webinar, CodeMap. As you introduced, I'm Manvi. I'm an undergraduate student. I'm a competitive coder and a backend web developer, and the founder of the coding club Girl Coded. So that's a bit about myself. And moving on to what's CodeMap and why this topic. So as the name suggests, CodeMap, it's kind of a roadmap for a beginner in technology. So when you enter the world of technology, there are a lot of things to learn, a lot of tracks to follow, a lot of tech stacks to learn. Usually people, beginners, students, confused with what they shall learn, how they shall learn. So today I'll try to answer few of these questions, like as a beginner or maybe as an intermediate developer or a coder, what you need to do to progress further in the field of technology. What's the right track and what's the way to go there? Okay, so let's start. Why roadmap? Like the first question is, why do we actually need a roadmap? So what's the first thing you need to know before you start? Destination, right? Like if you're standing somewhere and you need to go at any other place, you need to know where you need to go, right? So that's what happens. Same goes for technology. The world of technology is full of a lot of things. As you can see in the picture, there are a plethora of things, plethora of pictures describing different technologies in this picture. So while you enter the technology world, you get to listen a lot of buzzwords, including competitive programming, web development, Android or iOS development, machine learning, artificial intelligence, deep learning, cloud computing, etc., etc. And there's a lot more. So we would start by categorizing the type of codings. Like what we need to do at the end of this presentation, at the end of this webinar, is to actually get a glimpse of like what needs to be done, what are the possible options. So we'll just categorize our options into two things. The first thing is competitive programming and data structures and algorithms. Like they make the one category of learning, and the other things, including web development, Android development, machine learning, all these things make another category. Okay, so why it is like this categorization? You know, the competitive coding and data structures part, it doesn't include any development, and it doesn't include any real world development, and the others are some sort of developments. Okay, so let's take a short trip on some of these adventurous track. So let's start with competitive coding. Like what the heck is this competitive coding? So competitive programming is an intellectual sport where coders race each other to solve the most algorithmic problems within a limited amount of time. Many of the computer science topics used while developing apps such as networking, GUI, and databases won't be showing up during these competitive contests. Sorry. They're all about your algorithmic problem solving ability. Sorry. Data structure knowledge. I'm sorry, just a minute. Okay, so where we were? So competitive coding is all about your algorithmic problem solving ability, data structure knowledge, and implementation skills. Like you make use of a lot of data structures like arrays, graphs, trees while doing competitive coding. So it's not related to any kind of development. It's not gonna give you a product at the end. You participate in contests, you get some ranks, you improve your algorithmic thinking. That's what happens in competitive coding. And also, it's not used in any of the companies. Like while you join some company for work, you will not be asked to do competitive coding. So then why should I do competitive programming? Like it's not, if I say that it's not used in any of the companies. So that's only the half part of the story. The other part goes like, though competitive programming is not directly used in any of the companies, but it has its own importance. Training for participating in programming competitions have several benefits. Like first, you will become a better, more efficient and less error-prone coder. Your implementation skills will improve. The next thing, your technical interviews will become a piece of cake. Yeah, most of the technical programming interviews, ask for data structures and algorithms. So if you are a competitive coder, data structures and algorithms are a piece of cake for you. So that's one of the things you can consider for learning competitive coding. Third, you will increase your problem solving abilities that will help you solve, design, and implement difficult real world programming problems and algorithms in the future. The next exciting thing is the top competitive coders. If you get good ranks at different competitions, you get to win a lot of prizes and trips to places around the world as you compete with and meet other motivated and smart students. And last but not the least, it's really fun. At least I hope it will be for you. So I think that covers like what competitive coding is and why you should do competitive coding, right? Okay, let's take a brief of what is web development. Like you guys already know, you use a lot of websites every day. For everything there is a website. So in layman terms, making the website is web development, but that's the layman terms. From an engineer's point of view, from a developer's point of view, web development is the art and science that goes into making websites, web applications, and related software that goes into running, maintaining, and updating it. It would include building front-end components and pages, back-end server-side code, connecting a database to the server, and connecting the backend to the front-end. Okay, if that felt like, arrows above the head, okay, I'll simplify things for you. I use two main words here, front end and back end. So web development is basically a combination of two things, front end development and back end development. Either you can find a front end web developer, a back end web developer, or a full stack web developer. So let's see what front end is. Like as the name suggests, front end is the part of the website or web application that is visible to the users, like the part which we interact with. That's visible to us. It's usually built using HTML, CSS, JavaScript, frameworks and libraries like React.js, AngularJS. And backend of the backend part of the website is the logic behind the front end. Like the user don't get to see it, but they can experience it. They experience it while using the website. It usually contains the core logic, authentication, and code to retrieve and store data to the database. Like whatever logic is happening while you're surfing a website is its backend, and the way you see the website is its front end. The backend can be written in a variety of different languages, with a new language being added virtually every day. There are a lot of possible tech stacks for front end as well as backend. The most notable ones for backend are PHP, Node.js, Django, Python, Ruby, Java, and so on. So I think that clears like what web development is. Okay. If you feel like being a designer or someone who would want to create websites for someone for a few things, then you might choose this track for you. Okay, we'll talk about that in the later part of the presentation. Let's go to the next interesting part, where machine learning, like it's one of the buzzwords these days. Okay, so what is machine learning? It's one of the buzzwords. It's one of the most intimidating topics these days. So what is machine learning? In simple terms, machines imitating and adapting human-like behavior is machine learning. As the name suggests, machine and learning. A machine can't learn, right? No, that's not right. Machines can learn. That is what machine learning is. How exactly? Like, what do I mean when I say that I want machines to learn? Okay, let's take an example. Let me ask you a quiz. If 3 goes to 9, if 4 goes to 16, if 8 goes to 64, then 9 goes to, yeah, 81. How did you come to 81? That's exactly the kind of behavior that we are trying to teach to machines. We are trying to teach machines to learn from experience. Like we learned 3 goes to 9, it's the square of things, 4 goes to 16, and then we knew that somehow 9 is gonna map to 81. So we are trying to teach machines to learn from experience, right? So the differentiation here from normal coding is that instead of programming a traditional if-then-else construct, which explicitly directs machine to take rule-based decisions, we instead create algorithms that allow them to learn to perform a particular task optimally, getting better and better with each iteration. What do I mean when I say getting better and better with each iteration? Like as a learner, if you learn something for the first time, you may not be good at it, but then you learn it again for the second time, you learn it again for the third time, and then you get better with experiences. In layman terms, that's what happens in machine learning as well. Okay, so machine learning algorithms use computational methods to learn information directly from data without relying on a predetermined equation as a model. So we can safely say that machine learning is about making decisions based on trial and error and is a more application-oriented version of statistics, right? So the basic idea behind machine learning is to make decisions based on certain amount of information you have. The algorithms adaptively improve their performance as the number of samples available for learning increases. Some common applications of machine learning that you can relate to. Okay, so if you can think of some applications that you find in your daily life. Okay, your personal assistant Siri or Google uses ML, uses machine learning. The weather predictions for the next week comes using machine learning. Win predictor in a sports tournament uses machine learning as well. And medical diagnosis dominantly uses machine learning. And something you would be familiar with, ever wondered how come media sites show you recommendations and ads matching closely to your interests? Like if you search for a bag and then while wherever you surf, you find a lot of ads about bags. They as well use machine learning, the recommendation systems. So machine learning is everywhere. Going a bit more deep into the types of machine learning, we can categorize machine learning into three main types: supervised learning, unsupervised learning, and reinforcement learning. What is supervised learning? As the name suggests, supervision. There is some sort of supervision in supervised learning. Like supervised learning involves finding patterns. You find patterns, you develop predictive models using both input data and output data. For some input data, you have some labeled output in supervised machine learning. Okay. Supervised machine learning can itself be of two types: regression and classification. What does classification means? Classification is sort of classifying things like image classification or identity fraud detection and diagnostics. You classify things. Maybe you have a lot of pictures and of animals and you want to classify them, like these are dogs and these are cats, that kind of classification. The other thing is regression. Regression is actually computing the value of something, some input data, and getting some particular value and not a decision for it. Like if you have a very famous problem, it is a very famous problem in machine learning. While you learn it, you have a house predicting model, like based on number of features you predict the price of a house. Like the price is a value, a certain value. So that's regression. Again, regression has a lot of types like linear regression, logistic regression. We will not go that deep into the types of regression, And I think that clears what supervised learning is, the idea behind supervised learning. Okay, so maybe we can just take a small example of supervised learning. Like you have some input data and you also have the output as well. Like there's a child and you tell the child and you show the child some photographs of some dogs and cats and you tell the child that it's a dog, it's a cat. So that's kind of a labeling to output. Like you tell that this picture is of a dog, this picture is of a cat. So there is some sort of labeling in the input and output. So supervised learning basically has both input data and output data. The patterns and the models are developed using both the input data and the output data. Okay, so I hope that clears what supervised learning is. Moving on to unsupervised learning. Unsupervised learning is just the opposite of supervised learning, as the name suggests. When I say opposite, what I mean is you find patterns based only on input data. You don't have a labeling for output, you just have the input data, right? This technique is useful when you're not quite sure what to look for. It's often used for exploratory analysis of raw data. Okay. And the third thing, reinforcement learning. It's kind of different from the other two. Reinforcement learning learns from trials to optimize a reward, learning from your mistakes, adjusting, and ultimately getting that maximized reward of your dream. That's some way to define reinforcement learning. Okay, we see reinforcement learning in learning tasks, in robot navigations, in the game AIs, in real-time decisions. Yeah, so that's I think all about machine learning. It's a great thing to learn and it's quite popular these days, and it's gonna be I think for coming decades. Okay, so now that we have a brief idea of what and the why of the things, like no, we know what is competitive coding, now we know what is web development, what is Android development, like on the same terms of web and Android, and what is machine learning. I know there are a lot of things which I didn't cover, like cloud computing or blockchain, but I think that's maybe the outside the scope of a beginner's learner's point of view. We know the why of the things, the why of the competitive coding, why of the why web development, why machine learning. Let's go over the hows of these things. So, how to get started in competitive programming? The pre-requirement for jumping into competitive programming is a good working knowledge of your favorite programming language and some basic data structures. C++ is by far the most popular language of choice for competitive programmers due to its speed, and most resources or solutions will probably be written in C++. Though it's not a hard and fast rule, you can go for Java or Python as well. But yeah, C++ is the most used language in the realm of competitive programming, as mentioned, because of its speed. Okay, so you have decided you want to do competitive programming. You know what it is. How do you do it? So the first step is you have to master the basics of data structures and algorithms, the basics of the language that you're using. If you're using C++, then the basics of C++. Secondly, you have to master advanced algorithms and data structures, right? Like you learn graphs, you learn trees, you learn heaps, and you learn some techniques like sliding window technique or segment trees, binary indexed trees, the matrix exponentiation technique. Like there are a lot of things when you enter the world of competitive programming. You'll get to know this when you start. Thirdly, you have mastered the basics, you have mastered algorithms and data structures. And the final step for being a master at competitive programming is just working hard and practice, and practice a lot. Okay, I have mentioned a link to an article which has a detailed roadmap and walkthrough of how to get into competitive programming and how to become a good competitive programmer. You'll get this link later, and I think that's it for competitive programming. Okay, let's see how to get started in other sorts of development, be it web development, be it Android development, or it's machine learning. So I would say if you are a complete noob, you do not have any idea of how things work, and you're starting it for the first time, go for a free course. Maybe choose a course from Coursera, Udemy, or Udacity, and like pick a tech stack. Like if you are choosing web development, you need to pick what technologies you're gonna work on, and accordingly pick a course, or maybe refer the official documentation as well. Like it's all depends on how you like to learn, like from documentations or from video courses. It's all about your choice, but it's necessary to get clear with the basics either way, right? Then do some personal projects. Get your hands dirty with personal projects. That's the best way to learn. Remember, doing a course never makes you a web developer. Like if you do a web development course and you think you're a web developer, then you're probably wrong. You need to do personal projects. You need to get your hands into things so that you can learn them and make use of them. So that's second thing, do personal projects. They're quite important. And then third, look for an internship. If you're a student, look for an internship, because that's gonna teach you how things in real world works, like how these companies works, how the big databases are managed, how things work at larger scale. The personal projects you work on teach you the basics again, and some advanced concepts too, but you don't get to work on large scale products. While you intern for some companies or do some work, you get to work on a large scale. You get mentorship and some perks and incentives as well. So that's about learning web development, Android development, or machine learning. Okay, so but how do I know what I'm passionate about? How do I pick my destination? Like that's the question, no? That's the first question that we had when we begin. So yeah, that's one of the critical questions. There are a plethora of options. How do you pick one? One thing is you automatically have an interest for something. Like you are good at maths, maybe you're good at statistics. You may choose machine learning to learn. If you have a fascination for making Android apps, you may go for that. If you feel like making websites, you may choose web development. And for competitive coding and data structures and algorithms, I would say every aspiring software engineer should do that, to some extent. That's not a choice, matlab, like it's more of a necessity. And like if you want to become one of the best coders, then that's a different thing. You have to indulge in it deeply. But yeah, whatever you do, you have to maintain data structures and algorithms knowledge. Okay, so that's about your interest. What if you don't know your interest? If you're not able to recognize and pick what you want to learn, I would suggest the following things to do. Travel some of the paths, like whose ideas, whose whats and whys may interest you. Basically, explore your interests by actually trying hands at them. Say for a week, learn the basics of web development and try to make a very simple project for the same. Just spend 2, 3, 4 days in learning the basics and make a very simple project. For the next week, try your hands at other things, like read some articles about machine learning, try exploring the type of machine learning algorithms, and see if this interests you. You know, as the picture depicts, maybe in the 3 to 4 days when you were doing web development, you didn't feel that great. But when you did machine learning, you felt like, yo, this is the thing for me. So take a take the right decision for yourself by actually exploring things and not just listening to what people say. Okay, the journal mistakes to avoid while you begin. Don't try to learn everything altogether. It's one of the things that people tend to do a lot. Like they're like, I want to do competitive programming as well. I want to be a web developer as well. And I want to do machine learning too. And I want to be an Android developer too. Stop, guys, stop. That's not the way how things happen. You can't learn things all together. Just, you may learn 2 or 3 things, but not all together. And not also, don't move to the new thing before being perfect at the first thing, before being good at the first thing. If you have picked something, like if you have picked web development, be good at it, do some personal projects, and then move to something else, right? So just don't confuse yourself with things. Second, don't get demotivated in the beginning because the beginning is always the hardest. And coding is one thing that may look a bit not interesting and not fun kind of thing in the beginning, but I assure you that with time, with some practice, it will be the most fun element of your life. Third thing, don't try to learn alone, find a community. A community is much needed for learning things. To learn things better, you need a community. So to learn more, to learn better, try to find a community. Fourth thing, never hesitate in asking your doubts. No doubt is a silly doubt. Whatever you don't feel like understanding, just raise your hand. Just ask someone, some of your seniors, maybe just go to Google, or maybe if you don't understand it through Google as well, ask your seniors or whoever can answer it. And don't think that it might be a silly doubt, because that one silly doubt can ruin your interviews in future if you don't clear it right now. Okay. So I would like to share some of the resources that you can use. You can find, like I talked about the free courses before. You can find some free courses at edX, at Coursera, at Udacity or Udemy. These are some websites which have paid courses as well as free courses. Like I think there is no need of going for a paid course. You can choose any of the free courses available. Just see the ratings and the number of students enrolled, and accordingly just take the course. For doubts, Stack Overflow is the community, stackoverflow.com. You can just put up your questions over there and you get your answers very soon. And also, like, there is a rare need of putting up your doubts there, because whatever you get us out, somebody else got that doubt earlier. So most of the questions are already answered, so you can refer them. Or maybe you can refer Reddit as well. You can find some good answers on Reddit as well. Okay, if you want to practice data structures and algorithms, I would recommend leetcode.com and Geeks for Geeks. Like whatever you feel like, you can just explore the interfaces of the two. They're equally good, but I prefer LeetCode. You can just start with the easy ones. There are 3 levels in LeetCode. While you open LeetCode, you'll have an easy section, a medium section, and a hard section. So start with the easy ones. Don't go to the medium or the hard ones, because that would be disappointing in the beginning. You can categorize the tags as well. Like you want to prepare for arrays, you can just put a tag of arrays over there and an easy tag and start practicing. Maybe just practice 30 to 40 to 50 questions of one topic, then move on to the other topic. Make a list of all the data structures and algorithms that you want to learn and practice them one by one on LeetCode or Geeks for Geeks. And if you want to learn them, like you don't have any knowledge of, you don't have any prior knowledge, then again you can go for a free course or some course at YouTube, and then practice. But remember, only a course is definitely not enough. You don't learn anything while you do a course. You just know the basics. You have to practice things at hands. So that's about data structures and algorithms. For competitive coding, the three most preferred sites are Codeforces, CodeChef, and Sponge. There are other websites as well. Topcoder is also a good name. So you can just log on to any one of them, whatever you feel like. Okay, that's looks better. You can go there and start practicing. You have a lot of contests running over there where people from all around the world participate. You can just participate, solve questions, and get your ranks and improve day by day. Like if you want to get better at your speed, I would suggest Codeforces. Codeforces has short contest, like they have 2 hour contest, and you really get good hands at practice. Codeforces has short challenges too, but it has long challenges as well, and like they have 10-day challenge, long challenge. You can go over there and solve them. And the most important thing, always absorb the questions that you do in a contest, because if you don't do that, I think the participation in the contest was useless. It was not that worthy, because you don't learn anything new, right? To learn concepts, you need to absolve the contests. Whatever questions you were not able to solve in the contest, read their editorials and try to solve them on your own again. And there is a website called as medium.com. You have a plethora of good blogs for the topics you find difficult to understand. So I really prefer learning the topics that I don't understand easily through medium.com. They have a really good set of blogs over there. You can even write your own blogs over there. Well, and apart from this, you can always refer the official documentation of the language you choose to learn. I think that's for this resources part. Okay, so I would like to conclude here. What we learned, what CodeMap concluded is explore the different options. Maybe trying hands at them, or maybe just having like, okay, this seems interesting to me. Just know what possible options are there instead of just choosing one thing by seeing what others are doing. Don't see what others are doing. See what you want to do, right? Select your favorite. You know what are the possible options? Select your favorite. Third, don't give up. Next, work hard and practice. Practice a lot. That's the key. And hurrah, you aced it. Yeah, so that's it. Thank you.